When you're doing stoichiometry, it's really, really important that you always start with a balanced equation, because that balanced equation is what gives us our mole-to-mole ratio, and the mole-to-mole ratio is what allows us to do stoichiometry. So to balance this, we would need a 4 in front of aluminum, 3 in front of oxygen, and 2 in front of aluminum oxide. I want to know if I have 80 grams of oxygen, how many grams of aluminum oxide can I produce from that? So you're going to write down what you're given. You're going to cancel that unit. That's always how you start. At this point, we're doing what we did before, where all we know is that 1 mole is the number of grams of something off the periodic table. So the only unit I can go to from here is mole of oxygen, because that's my conversion factor. 1 mole of something is the grams off the periodic table. So 1 mole of oxygen, 32 grams off the periodic table. Then I have to cancel mole of oxygen. And this is going to be my mole-to-mole step. I know that because I've canceled out grams of oxygen, I've canceled out moles of oxygen. I don't want to do anything else with oxygen. And the only way I can get from oxygen to aluminum oxide is my mole-to-mole step. So I'm going to put moles aluminum oxide on the top. In this step, in the mole-to-mole step, you get your numbers from the balanced chemical reaction. So 2 aluminum oxide, 3 oxygen. In my final step, I'm going to cancel mole aluminum oxide. And now again, because of that conversion factor, I can go to grams aluminum oxide. 1 mole aluminum oxide, add up 2 aluminums and 3 oxygens, you get 101.96. When you are calculating this, calculate everything across the top, calculate across the bottom, and then divide those two numbers. You're going to get 169.93. What I was given was 3 significant figures, so you always base the significant figures of your answer off of what you were given. So 169.93 can be 3 significant figures by making it 170 grams aluminum oxide, or always an acceptable option would be scientific notation. So 1.70 times 10 to the second grams aluminum oxide. This next example, I have 79.4 grams of aluminum, and I want to know how many grams of oxygen will react with that. So 79.4 grams aluminum. Cancel grams aluminum on the bottom. Go to mole aluminum on the top. 1 mole is the grams off the periodic table. So for aluminum, 26.96. At this step, this is where mole will be 1, because in my conversion factor, right, it's 1 mole is the mass off the periodic table. So that hasn't changed from what we've done before. Now I'm going to cancel mole aluminum. And this is my mole-to-mole step. So I'll go to moles of oxygen on the top. Get those numbers from the balanced reaction, 3 mole oxygen, 4 moles of aluminum. Finally, cancel mole oxygen. Go to grams of oxygen. And again, I'm back to using this conversion factor. 1 mole is the mass off the periodic table. This one comes out to 70.6. Oops, sorry about that. Grams oxygen. Last example here, start with a balanced reaction. I have 35 grams of water. I want to know what mass of hydrogen, mass means grams. So 35 grams of water. Cancel grams of water. I can go to moles of water next. So 1 mole is the mass off the periodic table, 18.2 grams. Then I have to cancel moles of water. And this is my mole to mole step, so I'm going to go to moles of hydrogen on the top, get my numbers from the balanced reaction. And then in my last step, cancel mole hydrogen, go to grams of hydrogen. 1 mole is the mass off the periodic table. This one's going to give you 3.9 grams of hydrogen. So that's always the process. You need to be careful that you're not being robotic and being like, this is always what I do first, this is always what I do second. Just think about what unit needs to cancel, what unit do I go to next. That's always the process when you're doing any of these conversion problems.